In this video, we're going to take a look at what redox reactions are and how we can define a redox reaction with a various different set of approaches. So let's start out with what are redox reactions. Well, redox reactions are reactions in which electrons are transferred. And what's happening here is one species is going to lose electrons, and when something loses electrons, we say it becomes oxidized, and then the other species is going to gain electrons, and we would say that's reduced. So if we look at this example here of A plus B, and the electron goes from A to B, then we would say that A is losing electrons or is oxidized, and B is gaining electrons or is being reduced. So we're really just looking at the transfer of electrons in redox reactions. Now, oxidation and reduction can be defined in several ways, and this can feel kind of confusing, but we're going to go through each one and see how they all fit together. So we're going to look at in terms of the loss and gain of oxygen, or in terms of the loss and gain of hydrogen, in terms of electron transfer, and in terms of oxidation state. So let's start out with defining oxidation and reduction in terms of oxygen gain or loss. So if we look at oxygen being gained or lost in a reaction, oxidation is a reaction where a substance gains oxygen. So we would say it's oxidized, and this is where it gets a little confusing because it is then called the reducing agent. And that's because it is reducing the other thing when it becomes oxidized. So the terminology is a little funky, but we're just going to go with it. Reduction is a reaction where a substance loses oxygen, and so it becomes reduced, and it is called the oxidizing agent because it is oxidizing the other thing. So looking at our example here, we have copper 2 oxide reacting with hydrogen gas to form copper and water. If we look at our copper 2 oxide, then we can see from there to the copper on the other side, we have a loss of oxygen. And so we would then say that that has been reduced, or that is our reduction, and copper 2 oxide would be our oxidizing agent. If we look at the hydrogen to water is gaining oxygen. And so when something gains oxygen, that is oxidation. And we would say then that the hydrogen gas has been oxidized, or we could say the hydrogen gas is the reducing agent. So that's how our definition works in terms of oxygen gain or loss. Now, in some cases, one substance can be simultaneously reduced and oxidized in the same reaction, and this is referred to as something called disproportionation. So again, terminology, but it's okay. If we take a look at this, we've got potassium chlorate going to potassium perchlorate, and we also have potassium chlorate going to potassium chloride. Now, if we're looking in terms of oxygen, the potassium chlorate is reduced, so this is our reduction to KCl because we're losing oxygen there, but it is oxidized to potassium perchlorate because it's gaining oxygen there. So we have one reactant going to two separate things. So it's being simultaneously reduced and oxidized. So this would be a disproportionate reaction. Now, our second definition is oxidation and reduction in terms of hydrogen gain or loss. So oxidation is a reaction where a substance loses hydrogen. So we would say it's oxidized, and it's also the reducing agent. So that part hasn't changed. If we take a look at our reaction here, HCl going to Cl2 is a loss of oxygen. So that would be oxidation. Whereas our oxygen to our water would be reduction because it's a gain of hydrogen. And so looking at our second reaction here, if we look at our C2H4, our product C2H6 has gained hydrogen, so that would be a reduction as well. So we can define oxidation and reduction in terms of hydrogen loss or gain as well. Now our third way, and this is what we tend to think of redox reactions as, is in terms of electron transfer. And so oxidation is, in this particular definition, is a reaction where a substance loses electrons. Whereas in reduction, it gains electrons. And you can remember this by the saying, Leo says Gur. So this stands for loss of electrons is oxidation, and gain of electrons is reduction. So that's one way for you to help you to remember how this works. This works really nice when we're looking at the formation of an ionic compound, because we know that sodium will transfer its electrons to the chlorine to create our ionic compound. So we would say that the sodium is losing electrons, so it's being oxidized, and chlorine is gaining electrons, so it is being reduced. So that's how we would define it in terms of electron transfer. Now, probably the most useful definition is defining oxidation and reduction in terms of oxidation state change. So this goes back to our previous video where we looked at how to figure out oxidation states, and now we can use them to figure out whether something's being oxidized or reduced. Oxidation is a reaction where the oxidation state increases for an atom in the compound, whereas reduction is a reaction where the oxidation state decreases. So it's easy to remember because reduction means going down. So the oxidation state number going down tells you that it's reduction, and then you can remember that oxidation is the opposite. So the way you would use this is you would go through and assign oxidation numbers for all of your elements in the compounds for your reactions. So if we start with zinc, zinc is 0. The sulfate would be -2. So that means copper's +2. The oxygen's -2. The sulfur would be +6. And then we would actually have the same numbers here. And then copper would be 0. So if we took a look, and we took a look at zinc, zinc goes from 0 to a +2 oxidation state. So we would say that that is increasing, which means that is our oxidation. If we took a look instead at, let's look at our copper goes from +2 to 0. So it is going down in oxidation number, which means it's being reduced. Okay. If you looked at the sulfur and the oxygen, they're not changing between reactants and products. And so that means they're not part of this redox reaction. Nothing's happening to them. It's zinc and the copper that are changing in oxidation states, which is what then is telling us is being oxidized and reduced. So we would say in this reaction that zinc is oxidized, or zinc is the reducing agent, and the copper 2 sulfate is reduced, or the copper 2 sulfate is our oxidizing agent. So that is 4 different ways that we can look at oxidation and reduction in terms of our redox reactions. That's it then for this video. We'll see you in the next one.